This conference will now be recorded.
Hello everyone, last day we have already seen different discussion regarding group 18. Today it will be complete, and we will complete it with application of these inert gases. Fine. And after that we'll discuss some problems which will be covering this total chapter, that is all the groups or in P block elements. Uses in gas discharge lamp. So this is also one kind of application. Here we can see this picture, which are basically the picture of discharge lamp, gas discharge lamp. Noble gases, we know that there is a reluctance to form chemical bond because their electronic configuration, if we see carefully, it is already fulfilled. So this reluctance of noble gases to form chemical bond, that is actually the key to make this type of lamps. So each of these noble gases, they have this unique property that they glow in its own color when exposed to high voltage. Now, exposed to high voltage means there is a huge amount of energy which will be able to transfer the electron from lower energy to higher energy. So, as a result, what will happen? It will fall in the visible region and we can see some color. In this lamp, a high voltage electrical discharge is passed through a tube of low pressure gas. So, we will take the gas in low pressure condition in tube, and this high voltage of electric discharge, it has to be passed through this tube. So this electrical discharge, it will excite electrons in neon atoms. So see, for neon the color is the most intense color, causing them to jump from low lying energy level to high level. So it breaks Lewis rule of 8 electron in the outer shell, and that is the reason high energy is required, because according to Lewis rule, outer shell, it must contain 8 electrons, and inert gases, they also have 8 electrons, NH2 NP6, but still one electron will be removed when electrical discharge is applied, and as a result one electron will be removed from NP6, and there will be, that is the corresponding energy. If we consider, it will fall in the visible range and we can see some color. And color will be basically observed when the excited electron relaxes back to the lower shell, it sheds some energy. So this wavelength of light, it will depend on the difference in energy between higher and lower shell. So when we are changing the noble gas, that is helium, neon, argon, krypton, xenon, different colors we can see. So it depends on the difference in energy between the higher level and lower level. Each element gives off different color because of this different shell where the electrons will jump up. Okay, so that is why different color for different gases. Now mostly in advertisement purpose, this neon color is used, which is the most intense color. Okay, but all of these can generate this type of color in gas discharge lamp. So now we'll see the application of all these noble gases. They are widely used in different fields, starting from incandescent lighting to excimer laser. Helium, that is the first element if we consider in this group, it is utilized to fill aircraft and weather balloon because it is flammable and has a low density. So as it is low density, it can easily float. So that is the power. It is that is the reason it is filled in the weather balloon and fill aircraft. Liquid helium discovers used in cryoscopy to get the low temperature. So cryoscopy process, it is related to low temperature, and low temperature can be observed when we are using helium, that is liquid helium, because normal condition it is gas, but when you are converting it to liquid, obviously it is very low temperature. It is mainly used to cool the superconducting magnet, and this magnet utilized as a part of atomic magnetic resonance spectrometer. Helium is also utilized to weaken oxygen in the oxygen cylinders carried by the sea divers while diving. So the oxygen cylinder, it is not containing purely oxygen, there is also some amount of helium mixed with it. Then air is widely used to provide an inert atmosphere in laboratory apparatus. So in laboratory apparatus where we need a condition which is free of oxygen. That means if you are doing any reaction which is oxygen sensitive and you have to create inert atmosphere, in that case argon can be used. Though there is another gas that is also used, and that is nitrogen. And for metallurgical processes also it has application such as welding, stainless steel, aluminium and magnesium. After argon, the next two elements, xenon and krypton, they are used in light bulbs. And these light bulbs are not just ordinary light bulbs. There is that is, these bulbs have special purpose. So the ordinary bulb that you use in household purpose, that is not containing xenon and krypton. Remember, these are for special purposes. Then the next one, Rn, it finds use in radiotherapy because it has radioactive property. That is the reason it can be used for the treatment of cancer also. Okay, any doubt? Next we'll see problem in group 18. Among noble gases starting from helium to xenon, only xenon reacts with fluorine and it can form stable xenon fluorides. Remember, xenon fluoride, different types of xenon fluoride are there. XeF2, XeF4, then XeF6. But the question is why xenon is only the element for which you can see a variety of compound. Why not other elements? What is the reason behind it? That we have to find. There are 4 different reasons given in option A, B, C, D. The first reason, it has the largest size. Now if we write them down the group, helium, neon, argon, krypton, xenon. So xenon is the last element among these 3 because it is saying helium up to xenon. It has the largest size. Now this is correct, but not just that is, statement may be correct, but is it the actual reason for which xenon is making maximum compound? Next reason is given option B, it has the lowest ionization enthalpy. Now we know that as we are moving down the group, size increases, so removal of the last electron, that will be facile process because the valence electron that you are removing, that is far from the nucleus. So attraction of nucleus towards this electron is very less. So you can easily remove it. So ionization enthalpy lowest for xenon, that is also true. Then the next statement, highest heat of vaporization, and the fourth statement, most readily available noble gas. Now actual reason is option B. Okay, that is lowest ionization enthalpy. Now why not the other options are correct? The first option is largest size. Now it is true that it is large among all these 5 inert gases, but we have to find reason for which xenon is making various types of fluorides. Now to make this type of fluorides, obviously there will be different oxidation state, +2, +4, +6. That means you have to remove some electrons. And when removal of electrons will be easy, when ionization enthalpy is very low. So that is why this is the actual reason. It is also true that it is largest in size, and that is why you can easily remove the electrons. But actual reason is ionization enthalpy value is low, so you can easily remove electron and it can take part in reaction. Another 2 reasons, that is high state of vaporization, this is not correct, and most readily available noble gas. Now this is the statement itself is not correct because the most available noble gas it is not xenon. Okay, because if you consider natural occurrence in air, overall, that is considering all the gases, it is around 1%, and among this 1%, argon is the most available. So xenon is not most available. Okay, correct option, second one. The color discharge tubes for advertisement mainly contain which of these noble gases? Now all these 4 examples are noble gases: xenon, then helium, neon and argon, right? Now we have already seen all the colors in the first slide, and there we have seen that for neon the color is most intense, right? So that is why neon is used for this type of advertisement, and the color is highly intense red. So this will be the correct option. Next question. The elements which occupy the peaks of ionization energy curve. That means if you draw ionization energy curve starting from atomic number 1 up and you will increase the atomic number gradually. Okay, so in which case there will be peaks in the ionization energy curve. So suppose you have you are drawing a graph like this where all the elements are present, atomic number is increasing gradually, and ionization energy value that will be in the y-axis. Okay, and there will be a graph like this. Now see, these are the peak points. That means if you consider the corresponding element, that is the Z number I am talking about, atomic number. For these elements, you are getting these peaks, right? So the question is asking, what are those elements for which peaks of ionization energy curve will be observed? Now, peaks of ionization energy means what? Here, these values are very high because in the y-axis you have taken ionization energy. So basically, the simple meaning of this question is, what are those elements for which ionization energy is maximum? So that is why you are getting peaks. So it is not, the question is not framed very simply. It is not asking that for which ionization energy will be very high, because in that case the question will be very flat. But it is asking in terms of peaks of ionization energy, which means nothing but highest ionization energy is possible for which of these option. Now see, in option 1 we have all the group 1 metals, sodium, potassium, rubidium, cesium. Then in option B, here sodium, magnesium, these are from S block. Then chlorine and iodine, that is from group 17. So different groups are there. Then in option C, all these are group 17 because all these are halogen. And the last one, all these are group 18 elements, right? Now if you consider the periodic table, when you are moving along the period, the last one is group 18, right? And when you have reached group 18, it is already fully filled configuration. Now fully filled configuration means what? When you are trying to remove electron, that means you are breaking this stable full filled configuration, which is highly energy requiring process, because it will try to remain in this state. So removal of electron is not easy. So that is the reason maximum ionization energy will be for noble gases, okay, along any particular period. Now look at this picture. Ionization energy in electron volt unit in y-axis and atomic number in the x-axis, 0, 10, like this. So see, we are getting peaks like this. Now if you draw a line over here, it is somewhere around 2. Then for neon, it is at 10 because it is its atomic number. Then for argon, just draw a line, it is around slightly lesser than 20. That means for argon it is 18. Okay, so in this way you will see all the peaks that you are getting, the corresponding atomic number. If you see, all these are atomic number for noble gases. That means which option will be correct? Can you tell me? Among these 4 options, A, B, C, D, which one will be correct? Then radon. So we are seeing here some peaks, 1, 2, 3, 4, 5, 6. Total 6 peaks we can see. So which one will be correct option? First option, it is containing S block metals. So for metals we are not seeing any peaks. Then for option B, here you have group 17 and group 1 and 2. Sodium group 1, magnesium group 2, and Cl and I, these two are from group 70. So this is also not correct. Third option is also not correct, but last one is correct because it is containing all the noble gases, right? So is there any doubt? Next question is related to adsorption of noble gases. Charcoal, that is basically nothing but carbon, which is maintained at minus 100 degrees centigrade, minus 100 degrees centigrade, is very low temperature. It will absorb which of these combination of gases? Okay. Here the options, if we see, all are basically noble gases. Neon, krypton, helium, argon, argon, krypton, xenon, helium and neon. Now if we write them down the group, okay, as we are moving down, size increasing. Now when size is increasing, atomic mass, that is also increasing. Now when atomic mass will increase, the adsorption tendency of the gases, that will also be very high. Okay, because when liquefiability of the gases are very high, adsorption tendency is also very high, and liquefiability tendency will be increasing when atomic mass is also increasing. So that is the reason when mass is increasing, that is down the group, adsorption of these gases in charcoal, that will be very facile process. So as a gas having high atomic mass, it will have greater intermolecular forces of attraction. Okay, greater intermolecular forces of attraction means suppose dipole-dipole interaction or induced dipole interaction. So that is the reason it can be liquefied very easily. Remember, in surface chemistry chapter, we have already seen this. What is the actual reason behind it? That when intermolecular forces are very high, the liquefiability tendency, that is also very high. So that is the reason. Now the gas which is easily liquefiable, that is high atomic mass, interatomic forces of attraction high. That is the reason liquefiability is also high. And when liquefiability is very high, adsorption tendency is also very high. So that is the reason extent of adsorption will increase as the atomic size of the noble gas will increase. Now if we consider all these combination, the first option is combining neon and krypton. Second option, helium and argon. Third option only, C, it is containing all the high atomic mass gases. That is down the group you have these three gases, right? So that is why this will be the correct. And last one obviously not correct because these two are having very low atomic mass because they are the first two members. Fine. So this is the reason, and this is a correct option because it is containing all the high atomic mass noble gases. Any doubt? Which one of the following reactions of xenon is not feasible? Here we have total 4 options. All the options you can see some reactions of xenon compound, that is xenon oxide, xenon fluoride, and we have to find in which case the reaction is not feasible. That is not the reaction. It cannot take place. It will not be spontaneous. The first option is xenon O3, that is xenon trioxide. It is reacting with hydrogen fluoride and it is converted from oxide to fluoride and water is removed. Next is we have, that is the next 3 options. All are basically xenon fluoride, right? Different types of xenon fluoride, XeF4, XeF2, XeF6. Now these 2 options are similar type because it is hydrolysis, because it is reacting with water. Hydrolysis of XeF2, XeF4, XeF6, all these we have already discussed in the last class. So hydrolysis of fluoride, it is possible, and depending on what type of fluoride you have taken, different types of products are there. In both cases, xenon will be produced, but when it is XeF4, these are the product combination. This is half oxygen, but when it is xenon F2, there will be formation of O2 HF but not XeO3. And if it is reaction with XeF6 with water, though that reaction is not present, then it will be very vigorous, because here oxidation state +2, this is +4, and when it is hydrolysis of XeF6 with water, this will be highly vigorous, very it will take place very spontaneous. Why? Because compared to XeF4, XeF2 now oxidation state is very high, so that is why it will be easily hydrolyzed, and there will be formation of xenon O3 and HF. Now look carefully. This reaction is the reverse reaction of option A reaction, right? Reverse of this one. Okay, that means if this is very spontaneous reaction, the reverse reaction is not spontaneous. That means if we consider this arrow compared to this arrow, it will be always, there will be a tendency to move from right hand side to left hand side. That means this reaction is not feasible, because this compound is XeF6. It is very that is, its reaction with water is very spontaneous. That means they cannot remain like this. When a reaction is feasible, it means what? When you are reaching from left hand side to right hand side, the right hand side species should be very stable. Then only the reaction is possible. But if it is not possible, that is, if the stability is not present, obviously it will not move towards product. So that is why the first option will be the correct option. This reaction is not feasible. And last one, that is also feasible, because remember in last class we have discussed that xenon fluoride in presence of fluoride ion donor. So this is fluoride ion donor and also fluoride ion acceptor. Both these type of compounds can react with xenon fluoride, and here it is fluoride ion donor. XeF6 is accepting one FF minus ion. That is why now it is converted to XeF7 minus, and that negative charge is balanced by rubidium +1. So this is also possible reaction. So only the first option reaction, that is not correct. So is there any doubt why the first option is
No, ma'am.
correct? Okay. Next one. Here we have 3 fluorides given. We have to find out number of lone pairs of electrons present on xenon atom. Now xenon atom is the central atom for these 3 molecules respectively. That means number of lone pair in XeF2, then XeF4. So the first number that will be for XeF2, the second one for XeF4, and the last one that is for XeF6. Now xenon, here 2 ways you can solve this problem. First of all, you can use this formula that we have already seen. Number of valence electron, monovalent atoms attached, plus minus charge. Now plus minus charge you don't have to consider, because all these are neutral molecules. Another way also you can solve it, that xenon we know when it is in ground state, it is NH2 NP6. Okay. Now when it is in excited state, depending on how many unpaired electrons should be required, some pairs we have to break. Now when it is XeF2, there should be 2 xenon fluoride bond. That means at least 2 unpaired electron required. So if you break one of these pair, and if one of this electron is now in 3D like this, sorry, not 3D, I mean ND in general, you don't have to know what is the period number.
Can I ask you please, right?
Yes. Yes, tell me. Any problem? Is there any problem? Should I repeat any part? So now we have 2 electrons. So these 2 electrons